Hi. Today we're going to look at some problems where you have to solve right triangles using sine, cosine, and tangent. We'll be having more videos where you use like the law of sines and law of cosines. But these I think are, well, we'll see what we need to do on this. So these sheets come from supplementary stuff that goes with Forster's texts. And let's look at this. Okay, so number one, they're giving us a right triangle. They're telling us what the right angle is. And we need to solve the triangle, basically, find the missing side and angle measures. So what I want to do pretty much for all of these is draw or sketch a right triangle. Then I'm going to label it with the information that they give us. So triangle ABC, the right angle is at A, so the B and the C can go in either one of the other places. It tells us that the side opposite A, the little a, is 12, and the measure of angle C is 32 degrees here. So we need to find the other angle. Now this is going to be triangle sums. Let's go ahead and do that. 180, take away 32, take away 90. Is 180 minus 122 gives us 58. So angle B is 58 degrees. And we need to find these sides. If you've already gone ahead and you've done stuff with law of sines, you could do like maybe sine of 90 over 12 is equal to 32 over x or 32 over y or whatever. But this is more easily done, I think, by using sine or cosine or maybe even tangent. So let's look for this side AB. We'll call this y. We've got an opposite side, and they're giving us the hypotenuse of the triangle. So opposite with hypotenuse goes with sine. So we're going to set up sine of 32 is equal to y, which is the opposite side, over 12. So 12 times the sine of 32, when you multiply both sides by 12, is going to be equal to y. So we can find out what the y side is. Let's go ahead and do the x side, and then we'll do the calculator like in one fell swoop and take care of it. So let's call this x. To find out x, now we could use 58, and x would be opposite the 58 with the hypotenuse. That would be a sine problem. I usually try not to use a calculated value. It wouldn't matter really in this case, but I'm just going to stick with sine of 32. Now x is the adjacent to 32. Adjacent sides make up part of the angle. Opposite sides are opposite. Like you take out the hypotenuse, opposite the right angle, and then your choice is it an opposite or is it an adjacent side to the angle? If it makes it part of the angle, it's adjacent. If you're looking across at it, it's an opposite. So x is an adjacent to the 32, and we have a hypotenuse. So that's going to be cosine. Cosine adjacent hypotenuse. So we're going to say cosine 32 is equal to the adjacent side, which is x over 12. So 12 cosine 32 is going to be our x. Let's get the calculator out here and see what we have. So let's see, clear up. We're going to do cosine 32, or 12 sine 32 for the first one. So I have to do 12 times 32 sine, it's a little bit backwards on these older calculators, is 6.35. Now, are they telling us anything about rounding? They're not telling us anything about rounding. This is to a whole number, so I might want to go one decimal, so 6.4 for y. And it doesn't give us any units, otherwise we'd have to add units in there. For the x, we're going to do 12 cosine 32. So 12 times 32 cosine equals is 10.2. So we have completely solved the triangle. They gave us an angle and a side. We found the other side. We know the 90, and we found the two opposite sides there. Okay, let's look at, say, number 4. I'm just kind of randomly picking some of these here. So for number 4, we're dealing with triangle MNP. Now the triangle doesn't have to be to scale. It's just really to kind of organize. It's like a graphic organizer. Just need a generic right triangle. The right angle is an N for this one. So we've done 4. We did 1. The measure so in the M and the P can be any place else, either one of those others. Little m, the side opposite angle M is 20, and the measure of angle P is 31. Okay, so we need to find x, and we need to find the hypotenuse. We'll call that C. We need to find those two sides. So let's look to find C to begin with. C is a hypotenuse, and using the 31 that they gave us, 20 is an adjacent side. So we have an adjacent with a hypotenuse. Adjacent with hypotenuse is going to be cosine. So this is going to be set up as a cosine 31 equals the adjacent side, which is 20, over the hypotenuse, which is C. Now, in this case, we have C in the denominator, so it's going to take 2 moves to get it out of the denominator. Multiply both sides by C, so C cosine 31 is equal to 20, and then divide both sides by cosine 31 to get C by itself. C is going to be 20 divided by cosine 31. So that's going to find us our C. And let's go for the x. X is opposite the 31, and we have 20 as adjacent to the 31. So now we have an opposite to the 31 with an adjacent to the 31. So that's going to be a tangent problem. Tangent goes with opposite and adjacent. Let me switch colors here. So the opposite side is an x, so we're going to say tangent 31 is equal to x, which is opposite, over the adjacent, which is 20. Get 20 out of the denominator. 20 tan 31 is equal to x. And then the only other thing that we need to do is figure out what angle M is, and we can basically do that by using triangle sums. We have a 90 and a 31. That's 121, which leaves us with 59 degrees for angle M. 59, 90, and 31 add to 180 degrees. So triangle sums. Measure angle P plus measure angle N plus measure angle M equals 180. So that's pretty much how the triangle sums works. Another way to find this angle M, the harder way to find angle M in this problem, would be to use 2 of the calculated sides, and it's better not to use a calculated side when you don't have to, but once we find out, say, what C is, we could basically look at finding angle M as being like opposite. We've got an opposite side and a hypotenuse, and that's going to be an inverse sine problem. But we don't really need to do that for this one. The easier way to do it is just to straight out use sine, cosine, or tangent ratios. So let's see what angle C is. 20 divided by cosine 31. 20 divided by 31 cosine equals 23.3, rounded off to one place. So little c is 23.3. And we want to find out what x is. That's going to be 20 tan 31. So 20 times 31 tangent equals 12.01, so 12.0. So x is 12.0. And we have found everything in the triangle. We have solved the triangle. Okay, let's look at let's look at number 8. Number 8 looks like it might be an interesting problem here. So we're dealing with triangle PQR. So again, I want to sketch a reference triangle. And the right angle is at Q. So we've got PQR. R is a 12, so the side opposite R is a 12, and the side opposite P is a 24. So we know that this is a right angle, but we got to find the other two angles. If we find one angle, triangle sums, we can find the third one. And we can use Pythagorean Theorem and find this. Let's see. So I'm looking for, is there any kind of like a special pattern, like Pythagorean triple or anything? 3 times 4 makes 12. 3 times 8 makes 24. So I don't really see that we can do anything with like a 3, 4, 5. So to find Q, little q, I'm going to use Pythagorean Theorem. 12 squared plus 24 squared equals q squared. Q is going to be the square root of 12 squared plus 24 squared. So let's go ahead and do that straight out. So you got 12 squared plus 24 squared equals, and this is 36 times 20, which, so we'll just go for the decimal. It doesn't say that we need to do simplest radical form or anything like that, so I'm just going to straight out do square root of 720, and we get 26.8. So 26.8, one decimal place, 26.83 is 26.8. So Q is 26.8. Now what I want to do is, since this is an approximation, notice that this is an irrational number here, I want to try to avoid using a calculated value whenever I can, because this has kind of been rounded off. So I want to try to go with the numbers that they give me here. So let's look at angle R. I want to find the measure of angle R. So if we look at R, let's see what we have. We've got this hypotenuse that we calculated, but we've got 12 is an opposite to the R, and 24 is an adjacent to the R. So we've got opposite with adjacent. That's going to be tangent. So I'm going to say tan R equals opposite, which is 12, over adjacent, which is 24. Now you may know your special triangle, or your special angles. You get 1/2, but we have basically tan R is 1/2, which is 0.5. To find out what R is, we need to find inverse tangent of 0.5. So tan minus 1 of 0.5 is going to give us the measure of angle R. So I'm going to do put 0.5 in the calculator, and I'm going to do second tangent for tan minus 1 of that, and I get 26.56. We'll call that 26.6. So R is 26.6. And we could now do 90 and 26.6 and find angle P and just use triangle sums and be done with it. Just for the heck of it, I'm going to go ahead and do the same thing for angle P. 24 now is opposite and 12 is adjacent. So I'm going to do tan P is equal to 24 over 12, which is 2. So tan minus 1 of 2 is going to be the measure of angle P. So I'm going to put 2 in the calculator and then do inverse tangent, and I get 63.4. So measure angle P is 63.4. So we got the measure of angle P, got the measure of angle R. They gave us the measure of angle Q is the right angle. They gave us the two sides, and we found the length of the hypotenuse. So let's see. Different combinations of these can turn up. You just have to go with what you're given. Try not to use a calculated value, and you may have to use Pythagorean Theorem sometimes, but all these are pretty much straight sine, cosine, or tangent problems. Okay, thank you for watching this video. If you thought this was useful, let me know in the comments. And if there's anything else that you would want to see with any area of mathematics, let me know. Thank you.